Right, the topic is simple and compound interest. Simple interest is something you charge family members. Like if you borrow money from your parents to buy your first car, you charge simple interest. Compound interest is the rest of the world. Generally, banks perform this way. For example, interest on a savings account will probably be compounded monthly, or some kind of investment is compounded monthly. Right. There is a third form of interest, but we won't be covering that. That one's when it's compounded continuously. We will not be doing those. Okay? Alright, so let's talk about what these letters represent. So this is the formula for simple interest. And P will represent the principal, or the amount of money you borrowed. R is the interest rate. Generally speaking, it's in terms of years, right? It's like 2% per year. And T is going to be time. And again, generally it's going to be years. But it doesn't have to be years. Depends on how frequently you're charging the interest. If it's a daily rate, then the T will be time in days. Right, up here, this is the compound interest. Compound interest is when the interest accumulates every time it's compounded. So if it's compounded monthly, you add the interest earned every month instead of every year. Okay. So P is the same thing as up here. R is the same. It's the interest rate again. N is the new variable here. N is the number of times in a year that the interest is compounded. Or calculated. Okay. What that means is, let's say you earn $6 of, let's say you have $1,000 deposit and you earn $6 in one compound period. That means the next time it calculates interest, it'll be calculated based on the $1,006, not the original 1,000. Simple interest is based on just the initial amount. So if you're charging simple interest, and you're going to do 5 years of simple interest, so it's $1,000, and then next year it's still, that interest is still based on the $1,000, original $1,000. When it's compounded monthly, after the first month it might be $1,005, then that next month it may be another $1,012, and it gets compounded with each new different amount. Okay? Alright, so let's look at this. So you don't have to worry about that when you're solving these problems, just use these formulas, right? We have the simple interest formula, we have the compound interest formula. Okay, and by the way, banks probably do something a little more complicated than this, as they charge you fees for various things, right? But by law, when they're giving you what their annual percentage rate is, you will notice on car advertisements something about an APR. So whenever they mention the APR, they still have to include the fees that they're charging you when they tell you what their APR is. Okay? All right. So let's say Bob borrows $6,000 from his parents and agrees to pay them 18.5% simple interest. He must pay them back in 5 years. So let's look at the formula. Right? I'm going to go ahead and just write the formula here. A equals P times 1 plus RT. So the principal here is $6,000. 1 plus the rate is 18.5%. You have to change that to a decimal, so it's 0.185. And the time is 5 years, so multiply that by 5. At this point, all you're going to do is just put it in the calculator. So I'm putting in the calculator, 6,000. Okay. Can't see too well. All right, 6,000 times, put in parentheses, 1 plus 0.185 times 5 years. So that's what we got. Put that in the calculator and you get $11,550. So you're going to end up paying your parents this much based on your initial loan of $6,000. All right. Part B. So it's another simple interest example. If you invest $6,000 at a simple interest, so it's 1 plus 0.06 times how much money we have after 10 years. Multiply by about 10 years. Put that in. So it's 6,000 times 1 plus 0.06 times 10. So that's all that is, right? That's the initial amount of 6,000. Put that in and you get 9,600. So that's what you're being asked to here. Let's look at C. If you invest $10,000 at 2.5%, so it's 1 plus. Now, this is compounded quarterly, so that means we have to use this other formula, right? So we're going to put the R on top, which is 2.5%. 2.5%, uh-oh, my screen froze. There you go. 2.5%, that's going to be 0.025 over compounded quarterly, so that means it's compounded 4 times a year. And you compound it quarterly, so it's 4 times, and then the number of years is 30. So that's what that is. It's 10,000, that's the original amount, 1 plus the rate in decimal form, that's 0.025, over the number of times it's compounded, so it's over 4, close parentheses. The first number is how many times it's compounded in a year, so it's 4 times, times the number of years. All right. I'm going to put this in the calculator. Well, you can't see it now. All right, 10,000. Oops. 10,000 times 1 plus, what was it? 0.025. 0.025 divided by 4. Close those. Raise it 2. And we want 4 times 30, or just do 120. Right? 4 times 30 is 120. And now have $21,120. $21,120.65. All right, let's round it to the nearest penny. Okay. All right. D. Warren purchased a car for $14,000. $14,000. Oops. All right, $14,000. 4.9% compounded monthly, so it's 0.049. Remember, you have to move the decimal 2 places. So that's over compound monthly, so it's 12. 72 months. So they gave you 72 months. So you don't have to actually write 72 times 12. It's given it to you. So the 72 is this. Is the 72 months is equal to 6 years. So they done the 12 times 6 for you. Okay. So you could just write 72 instead of 72 times something. They gave you the actual number of compounding terms. All right. Now we work this out on the calculator. So it's 14,000 times 1 plus, what is that, 0.049? 0.049 divided by 12. And we're going to raise that to 72. That gives us $18,773. It's $18,773 and 73 cents. That's how much you end up paying for a $14,000 car. You end up paying $18,773.73. Okay. E. When Jill was 27, she deposited $4,000 into an IRA. IRA is an individual retirement account. Okay. Where it earns 9.8% interest, compounded semi-annually. What will it be worth when she retires at 65? All right, so she's put $4,000 in. If the interest rate is 9.8, so plus 0.098. It's compounded semi-annually. That means twice a year, so just 2. Now 65. Figure out how many years it's in. You just subtract the 2. 65 minus 27, and you have 38 years. And it's compounded semi-annually, so twice a year, 2 times 38. And that's what you're going to calculate. Put that in the calculator, 4,000 times 1 plus 0.098 divided by 2, close parentheses, raise it to the 76, right? 2 times 38 is 76. And you get $151,000. $151,704.02. All right, that's a lot of money. consider you only start with 4,000, but 9.8. But keep in mind that was 38 years, right? If you just let money sit for 38 years, they can earn a lot of money, even if it's not 9.8%. Okay, but more than likely a bank will give 1%, not 9.8. That's how much that sale is if it's 1%. So that means you would just change the 0.98 to 0.01. 1%. So you get $1,800, right? If the initial amount was 4,000, you would get about $1,800. All right. Excuse me. All right. F is a weird one. Hopefully you follow through with the last example. So here, Margot opened a savings account 3 years ago at 4.3%, 4.35% compounded weekly. So that means it's 52 times a year. The account currently has a balance. So they tell you what it currently has. So that means $2,905.31 is equal to some unknown principal, right? How much money was originally deposited to account? That's the piece that's missing, the principal. Times 1 plus 0.0435 over 52 raised to the 3 years ago. So it's 52 times 3. So I'm going to put this piece in the calculator. So parentheses 1 plus 0.0435 divided by 52 raised to the 52 times 3. Now I'm going to take that number. So this long number represents this expression. Now I'm going to divide by that, divide $2,905.31 by that, by this, to get the actual principal. So 2,905.31 divided by that value I just got, okay? And that's going to be the original amount, $2,550. So my principal was $2,550. That was the original amount. Okay, so that's the video. I hope that was helpful. Have a good spring break.